This is AP Calculus AB, Worksheet 6-2, General Particular Solutions. The first part of all of these questions will just be to separate and integrate, doing the first two of the 4 steps to solve for the particular solutions. Let's jump straight in. In number 1, we have this fraction set equal to a fraction. Let's go ahead and work on our separation. Separate. I like in my homework to label what I'm doing, so I will write out separate and evaluate and integrate, and well, I guess it's separate, integrate, evaluate, then isolate each time that I do it, so you know what I'm doing for my notes. All right, so when I do my separation, I'm going to be cross multiplying. So I'm going to do my y's. I always do my y's first. So I'm going to say y times dy is y dy. That's going to be set equal to, okay, this negative has to belong somewhere. It's either the top or the bottom, but not both. I'm randomly saying that the negative is going to belong at the top, which means that this is going to be a negative 2x dx. Negative 2x dx. Let me color code that too. I'm going to go ahead and say that this is going to be a blue line, so let's multiply this direction, and I get negative 2x dx. So I'm just checking y is on one side, x is on the other. I got lucky for the separation. I didn't have to do anything else. So from here on, I just need to integrate. So step number 2 is to integrate. So when I put the integral symbols of y dy, this is going to be the integral of negative 2x dx. The antiderivative of y is y squared over 2. Technically plus c, but I'm going to put the plus c on the right-hand side. The antiderivative of negative 2x is a negative 2x squared divided down by the 2. I'll add my c now, and I'll simplify this to say that this is y squared over 2, which is equal to negative x squared plus c. And I'm not going to box that because it's technically not the final answer. All right, let's do that again. So just practicing those first initial steps. This is going to be separate. So just cross multiply. I do my dy's first. So this is going to be 2y dy. And that's going to be equal to, multiply the other direction. And this is going to be 3x squared plus 1. That entire thing multiplied by dx. Let's see. I am looking y's and y's, x's and x's, one's on one side, one's on the other, so check. And then I just have to move on to integrate. So for integrate, slap on the integral symbols on both sides. I have integral of 2y dy. It's going to be equal to the integral of 3x squared plus 1 dx. And taking the integral, this is going to be 2y squared divided down by 2 plus c, but I'm going to put it on the right hand side. And I'm going to take the integral of the antiderivative of each of these pieces. So there's really 2 pieces to do. This is going to be 3x, it goes up to the power of 3, divided down by 3, plus, and then the antiderivative of 1. I'm going to explain this once, and then I'm going to do the shortcut from here on out. This one is really 1x to the power of 0. So this power of 0 is going to go up to the power of 1, and this is now 1x to the power of 1. I divide down by that 1, which is a very fancy way of saying we just have an x there. And don't forget your cake, don't forget your plus c, your extra point there. And let's go ahead and simplify. 3's and 3's are gone, 2's and 2's are gone. So our final answer here is going to be y for the problem, but not for the actual, I guess, for this question, but not the actual problem. Y squared is going to be equal to x cubed plus x plus c. All right. And number 3, again, let's do the separate. Separate. So multiplying the dy's, I get y dy. And when I do the dx, I get x plus 1, that quantity, times dx. And man, yet again, I'm getting lucky. Y's and y's, x's and x's. It doesn't really matter where the ones go. And I'm done because they're on their own side. From here, I'm going to integrate. Integrate. When I integrate, slap on the integral symbols, and I have y dy is equal to the integral of that quantity of x plus 1 dx. And then from there, we're going to take the antiderivative. I'm going to start going a little bit quicker here. I know this is going to be y squared over 2. And that's going to be equal to x squared over 2. Remember the shortcut, whenever you have a 1, it turns into whatever variable. If you have a dy, it turns into a y. If you have a dx, it turns into an x. I'm dealing with the dx, so this turns into x. So this can be plus x, and then don't forget your plus c. All right, moving on to number 4. I don't have a fraction, so let's make it into a fraction. And let's do our separate. When I do my cross multiplication, dy times 1 is dy. When I do my cross multiplication the other way, I get 4y dx. And for the first time so far in the homework, we do have a mixing of y's and x's. This side is reserved for the x's, this side is reserved for the y's. So how do we get this y over? We can just divide. And here, this is up to you. You can choose, do you want to divide both sides by y, or do you want to divide both sides by 4y? It does not matter. I'm going to take the easier way and do less work and just divide by y, which means I have this new function that is 1 over y dy is equal to 4 dx. The 4 got left behind. I will note here in the video solution that having 4 or down here and 1 right here is a valid solution. You'll still get the same answer regardless, even after you integrate. You'll have to move things around later. So let's do the integrate now. When I do my integration, slap on the integral symbol of 1 over y dy, and this is going to be equal to the integral of 4 dx. All right, in the lesson, I fell into this trap on purpose of saying, oh, well, this is really y to the negative 1, because that's the same thing. And if I add 1 to this is going to turn into 0, and I divide by 0, and oh, no, that doesn't work. Every time that you see a fraction with a power of 1, you'll know when you're taking the antiderivative, this is log house. So this is going to be natural log, and you always take the absolute value of y, and this is going to be equal to 4x. Don't forget your plus c. And that's all we have to do to it. If you had decided to put this 4 over here, the answer would have changed a little bit. The answer would have been a 1/4 here with no 4 here. And you might say, but don't you have to like divide that one by 4 also? C can be any number at once. Sure, it could be divided by 4. It could also be multiplied by pi. You can do anything you want to it because it's just a number. It can be any number. It represents any number you want it to be until you have a specific condition like an x and y coordinate, like maybe it's 1, 2. Then we can't even figure out what C is until we're given that information. So moving on to number 5. Again, we do not have a fraction, so let's make it into a fraction. Cross multiplying for our separate. And I get 1 dy, which is just dy. Cross multiplying the other direction gives me a 2y squared dx. And yet again, we have a mixture of x or y's on our x side. We need to get rid of this y, so I'm going to move it to the other side. Again, I like to leave the number behind, but it is up to you on if you want to take it or not. So let's go ahead and divide both sides by y squared, divide both sides by y squared. And I now have 1 over y squared dy. So y's are on their own side, and 2 dx. 2's are on their own side, or the x's are on their own side. Separate, done. Now we go integrate. So when I do my integration, just slap on the integral symbol, integral of 1 over, I'm going to change the form here so I can save a step. I know that it's kind of hard to do the integration symbol here, or the antiderivative here. You might be thinking it's log house, but you would be wrong. So instead, I'm just going to say that this is really y to the negative 2 dy, and that's going to be equal to integral 2 dx. So now, when I do the antiderivative, this is going to go up to the power of negative 1. So this is going to go y to the negative 1, and you divide down by the negative 1, which is the same as multiplying by a negative 1. A little shortcut there. This is going to turn into a 2x over here. Don't forget your plus c. Technically, I'm done now, but I really don't like leaving negative powers when I know that I have evaluation ahead of me. So while this is done for the homework, but I'm going to go an extra step further and say this is really negative 1 over y is equal to 2x plus c. You could have also had that negative in the bottom. Again, it doesn't matter where you put the negative. It can be top or bottom or out front. It just can't be both top and bottom. All right. And then I'm moving on to number 6. Number 6, again, I don't have a fraction, so let's make it into a fraction. So let's go ahead and multiply this direction for our separate. And this is going to be 1 dy, which is just dy. On the right side, I have this x, y cubed dx. So to move the y over, we are going to divide by y cubed, divide by y cubed, and we're now left with our 1 over y cubed dy. That's going to be equal to x dx. You can see that we clearly have y's on one side, x's on the other. Therefore, we are done with our separate step. Moving on to integrate. For our integration, we are going to just slap on the integral. I'm not going to rewrite this because I know that whenever I have a power of 1, then it's going to be loghouse, but whenever it's other powers, I typically want to rewrite it in its negative exponential form, or the negative exponent. So it's going to be y to the negative 3 dy. It's going to be equal to the integral of x dx. All right, so when I take the antiderivative, this negative 3 goes up to the power of negative 2, so this is y to the negative 2, divide down by negative 2. And then that's going to be, supposed to write equal to, and then this is going to be x squared over 2, and don't forget your plus c. Again, I would be done here normally, but you should practice on how to get rid of this y to the negative 2. This really turns into a 1 over negative 2y squared, and this is going to be equal to x squared over 2 plus c. In number 7, again, no fraction, make it into a fraction, cross multiply here. We're going to get a, for a separate step, separate, we're going to get a 1 dy, which is just a dy. Should have done blue in the last one, but cross multiplying the other direction gives us a x square root of y dy. So you can clearly see that, oh, dy, dx, what am I talking about? You can clearly see that we have a square root of y on the x side. This x belongs, but we need to get rid of this square root of y. So what are we going to do? We are going to divide both sides by the square root of y. Divide both sides by the square root of y. And we now have 1 over square root of y dy on the left. And on the right, we have x dx. You can see that we clearly have x's on one side, y's on the other. We are done with our separate step. From there, we move on to the integrate. To integrate, we are going to slap on the integral symbol. I'm not going to write it like this, and I'm going to do two things at the same time. The square root of y is the same thing as the power of 1/2, and because it's on the bottom, I'm going to really move it to the top and make it a negative 1/2. So this is really a y to the negative 1/2 dy, and that's going to be equal to the integral of x dx. All right, so this is going to go up a power, up to the power of 1/2. So this is now a y to the power of 1/2, and I'm going to divide down by 1/2, which is the same thing as multiplying by 2. And this is going to be equal to x squared over 2, don't forget our plus c. And while that is enough to say that we have fully integrated, I would like to remind you that y to the 1/2 is a square root of y. So this is really 2 root y is equal to x squared over 2 plus c. And we're done with the front side. Let's move on to the back side. In number 8, again, we don't have a fraction, so let's make it so. It's a fraction. Multiplying for our separate step, separate. We are going to get 1 dy, which is just dy. And then when we cross multiply the other direction, we get, oh boy, y squared times this quantity of 6 minus 2x end quantity, all that times dx. All right, so I'm going to consider this entire term here. I was trying to do a curly brace. This entire term is an x term. This is the y term, and this y term needs to move over here. So we need to divide both sides by y squared, divide both sides by y squared, meaning that we have a 1 over y squared dy. That was going to be a dx dy. And that's going to be equal to a 6 minus 2x, still in parentheses, because all of it is being multiplied by dx. And you can see that x's are on one side, y's are on the other. Therefore, we are done with separate. Moving on to integrate. For integrate, we are going to put an integral symbol here, and I'm going to change this from a 1 over y squared to a y to the negative 2 dy, and this is going to be equal to the integral of 6 minus 2x, that entire thing in parentheses, dx. From here, I'm going to take the antiderivative. Antiderivative of y to the negative 2 is y to the negative 1. Divide down by negative 1, which is the same thing as multiplying by negative 1. You can just put a negative out front. And that's going to be equal to 6x minus, okay, be careful here. This is going to be x to the power of 2, and I divide down by 2. Those 2's will cancel, leaving us with the x squared. So minus x squared. And don't forget our plus c. And again, you're done, but I want to make sure that you know how to undo this. This is technically a negative 1 over y equal to this 6x minus x squared plus c. All right, moving on to number 9. Again, we don't have a fraction, so make it into a fraction. And then we're going to do our separate step. Separate. So let's cross multiply. 1 times dy is just dy. And this is going to be equal to, cross multiply the other direction, and I get this x squared times y minus 1 and times our dx. So this is the first problem where it's kind of tricky on how to do the antiderivative, just a little bit. This is more towards the area of the level of difficulty for an AP test. Notice again, we have this entire term is going to be our y term. This entire thing needs to be on our y side, and we can leave the x squared with the dx. So we are going to divide both sides by y minus 1, divide by y minus 1. And what is left over? On the left side, we have 1 over y minus 1. And on the right side, we have, where's my dy? I need to write the dy. And on the right side, we have an x squared dx. So you can check it out. Y's are on one side, x's are on the other. Now moving on to the integrate step. Integrate. I'm going to slap on some integral symbols here. And I'm going to keep this as 1 over y minus 1. I was debating on whether or not I was going to deliberately fall into a trap. I don't want to. I just want to do it the fastest way possible now. We've fallen into it a few times, so you know what to expect. It's going to be x squared dx. What I was thinking about writing was y minus 1 to the power of negative 1. You would take the antiderivative. You'd be like, oh, whoa, whoa, whoa. Do we need to pay the tax person? This kind of looks suspicious, like tax person. You'd be like, okay, the derivative of all this inside is 1. Okay, you don't need to pay the tax person. Then you still have this y minus 1 to the power of negative 1. You say, okay, add a power. It goes up to 0, divide by 0. And oh, no, you fell into the trap. I don't want to do that, so I'm just going to say, okay, we know this is going to be log house. And what is it going to be log of? It's going to be natural log of whatever's on the inside, absolute value of y minus 1. And then on the right side, it's going to be x cubed over 3. Don't forget your plus c. And you can't really simplify anything there, so we'll leave it. And number 10, we do have a fraction. Let's go ahead and say that the negative actually belongs in the top. So when I do my cross multiplication for my separate step, separate, cross multiplying the 2 times dy is a 2 dy. Cross multiplying the other direction gives me a negative xy squared dx. Again, this is the x side and there's a y, so let's go ahead and not have that y by dividing by y squared divided by y squared, and I now have a 2 over y squared is equal to a negative x dx. And this, oh, I did it again, darn it. I forgot my dy, so let me go ahead and move these, move these over, there we go. Dy. Okay, so there's the y side, check, x side, check. All right, moving on to the integrate step. Integrate. For the integrate step, we are going to have an integral. We do want to rewrite this one because whenever it's a power of 1 in the bottom, I typically like, okay, don't rewrite that. I know it's log house. Whenever there's a 2, I need to be careful here and say this is really a 2y to the negative 2. And this is dy equal to integral of negative x dx. All right, so when I take the antiderivative, this negative 2 is going to go up to the power of negative 1. So I really have a 2y to the negative 1, and then divide down by negative 1, which is the same thing as just having a negative out front. This is going to be equal to a negative x squared over 2 plus c. Don't forget the plus c. And again, I'm done, but I want to practice writing. How do I get the y with a positive exponent? It's really negative 2 over y, which is equal to negative x squared over 2 plus c. One thing that's kind of interesting about this problem, to me, is that there's a negative here and a negative here, and I don't care the sign of u. You could be a negative c. I mean, if you want to really flex on the AP graders, you'll change this to a minus c randomly, although that might mess you up if you're actually planning to do step 4, isolate. They don't matter. It doesn't matter. You could write plus 2c, and just laugh. Like, it doesn't matter what that number is. But here's the thing. I can multiply this side and this side by -1, and I could just get rid of the negative and get rid of the negative, and I still have the correct answer because I don't care what C is. Technically, you don't have to write a -C there. But I'm not going to. That might be confusing for people that aren't watching the video and they're just looking at the static answer key and asking, like, why did you get rid of the negative? Because I can. All right, number 11. Ooh, spicy. Number 11. Which of the following is the solution to the differential equation and it has an initial condition? Oh my goodness. And number 12, the same type. Okay. This is interesting because number 11 and 12 not only ask you to go a step further and evaluate, but also to isolate. So this is probably the part in the video where I'll say, you're probably tuning in now to figure out how to do this, and I'll tell you, you don't need to know how to do 11 and 12. If you leave 11 and 12 blank, I'm not going to take off points because I don't expect you to know how to do this, but I like doing it, so I'm going to do it. Here's how you do this problem. You will do all 4 steps. I believe you'll have to do all 4 steps. Let's try it. So separate. When we do our separate, we're going to cross multiply. dy times y is going to be y dy. And when we cross multiply the other direction, this is going to be equal to x squared dx. And at first you're thinking, okay, well, that's not too bad. The y's are on the same side. The x's are on the same side. Nothing to do there. By the way, why am I doing this? Why am I doing separate, integrate, evaluate, and isolate? It's because you see the words initial condition. Every single time you see initial condition, you automatically jump into those 4 steps. So I did step 1. Let's do step 2, which is to integrate. Integrate. When I do step 2, I'm going to slap on an integral symbol. This is going to be integral of y dy is equal to integral of x squared dx. And very quickly, that's going to be a y squared over 2, which is equal to an x cubed over 3 plus c. Cool. And then I'm going to do evaluate. So evaluate. And to evaluate, I'm plugging in our initial condition. So again, when it gives us extra information right here, this is telling me that the x coordinate is 3 and the y coordinate is -2. So let's go ahead and label that. So this y is going to turn into a -2. This x is going to turn into a +3. Rewriting that is going to give us a -2 in parentheses squared. If you just put squared without the parentheses, you technically will get it wrong. All over 2, and that's going to be equal to the x, which is 3. So 3 cubed over 3 plus c. And on the AP tests, they would be good enough to say you're done, except for the fact that this is a multiple choice question. They're forcing you to solve it. You have no choice but to do it all or just guess. So how are we going to do this? Let's simplify here. -2 squared is a +4. -2 times a -2 is a +4. And +4 divided by 2 is 2. That's going to be equal to. There's a cute little shortcut here that I always do in my head that I should explain. This is a 3 to the power of 3 and a 3 to the power of 1. If you have the same base, you can subtract these exponents. 3 minus 1 is 2. This whole thing is just 3 to the power of 2, which is just 9. That's how I always do them, but you could also do it the long way. 3 to the power of 3 is 3 times 3 times 3, which is 9 times 3, which is 27. This top is 27, and 27 divided by 3 is 9. You can do it that way too. That's not the way that I choose to see it. And then don't forget to write r plus c. And then we need to solve. So let's subtract 9, subtract 9, subtract 9, and you get c is equal to -7. Cool. And then you have to do step 4, which is to isolate, which we did not cover in the lesson. So in order to isolate, we're just plugging in c into our equation. Remember, our final equation, we got it right there in our integrate. The only problem is we didn't know what c is, and hey, I have a c, so I can plug it into this value right here, and I can rewrite this entire equation with the c included, which is y squared all over 2 is equal to x cubed over 3, and instead of saying plus c, I'm going to say -7. And at first you might say, okay, done, right? And you'll notice that all of these multiple choice answers have a y equal to by itself. Like the y is by itself. We need to get this y by itself. And that is the tricky bit of this entire process, and it takes a lot of work. So the first thing that I see is I can divide everything by 2. Or sorry, I need to get rid of this divided by 2. I need to multiply everything by 2. So I'm going to show my work here, multiply by 2, multiply this entire side by 2, and I'm going to now get y squared by itself is going to be equal to 2x cubed over 3 minus, and then 7 times 2 is 14, so I'll say minus 14. Cool. And then finally, we just need to take the undoing of the square, and we need to square root. So this is going to be y, and I'll write that here. We're going to square root and the square root, and maybe I'll write my answer with black. Oh, I meant to do an eraser there. We'll do this with black, and we'll say y is equal to, and be careful here, every single time that you do a square root, you must think about the positive and negative. It has to be plus or minus, then the square root of this 2x cubed over 3 minus 14, which looks familiar, right? I mean, you're wrong. But B and C look like potential answers. So which one is it? That one is the plus, and that one is the minus. I said plus or minus, and so the answer is C and B, right? No, you're wrong. We have to make sure that this works. So we have one final check. Even though we did step 4, there's like an extra hidden step 5. You need to make sure this actually still works. Plug in 3 and the output needs to be -2. I've done these problems so many times I say, I don't care what I plug in here. I know inside here has to be positive, and because the square root of anything else is going to be imaginary. So I know that has to be positive. How can I get a y value? This y value is -2. Which one am I going to choose, a positive or a negative? And it's pretty clear. The y is a -2, so we have to choose the negative. And the correct answer here is C. But if I do this the long way, I'll show it to you. We're going to plug in our x value of 3, and I will prove to you that it is indeed the negative. So if I plug in 3, I'm going to say that this is, plugging in, so I'm going to say, it's going to be -3. That was the y value, right? Y value was -2. I apologize. So the y value is -2, and that's going to be equal to, we don't know, is it the plus or is it the minus? And then we're going to say the square root of, the square root gets smaller and smaller at each step. It's making it hard. 2 times the x coordinate, the x coordinate was 3. 2 times 3, quantity cubed, all over 3 minus 14. All right, we're going to do some simplification kind of in our head real quick. 3 cubed is 27, divided by 3 is 9. I did it the way that you probably would do. I like saying it's 3 cubed over 3 to the power of 1, which is 3 squared, which is 9. Anyway, this is 9 times 2, which is 18. And 18 right here minus 14 right here is 4. This is the square root of 4. So I'll say this is going to turn into -2 is equal to plus or minus square root of 4. Therefore, -2 is equal to plus or minus 2. Well, which is it, the plus or the minus? I wanted to get this -2, and the answer is clearly minus, so we can go ahead and, there's not an official way to do this, but I'll say, I'm going to cross out that plus sign. No, that was not a plus sign, or I can just circle C. It had to be a plus sign, or it had to be a minus sign. I apologize. All right. Lots of work for those problems. I warned you. All right, number 12. Which of the following, okay, we got to do the whole thing again. This one looks a little bit, no, they're roughly the same difficulty. Here we go. We're going to separate. Whoa, not too far back. We're going to say separate. So separate, where is my original equation? There it is. So it's let's go fraction equal to fraction, so that's kind of nice. Y dy, y dy, whoa, it's supposed to be a y. And this is going to be cross multiply this direction. This is going to be 4x dx. So this is going to equal to 4x dx. And lucky us, we don't have to worry about x's and x's, y's and y's. They're on their own side. So done with separate. Moving on to integrate. So I'll say integrate. When I'm doing my integrations, I'm just slapping on integral y dy equal integral of 4x dx. The integral of y is going to be y squared divided by 2. The integral of 4x, remember that this 4x is going to go to a power of 2 and then divide by 2, which means 4 and 2 are going to cross cancel and turn into a 2. This is really 2x squared. Don't forget your plus c. Then we move on to the evaluate step. Evaluate. When we evaluate, we're just plugging in. What are we plugging in here? We're plugging in the x coordinate of 2 and the y coordinate is -2. So the y coordinate is -2, so this is going to be -2 quantity squared. Again, I'm rewriting this equation, but you are -2 and you are +2. So all over 2, and that's going to be equal to 2 times +2 squared plus c. All right, very quickly, negative 2 squared is 4, and 4 divided by that 2 is 2, so I'm going to have a 2 on this side. On the right side, I'm going to have 2 to the power of 2 is just 4, and 4 times 2 is 8, so I'm going to have an 8 here, and don't forget your plus c. If I subtract 8 on both sides, c is equal to negative 6. All right, finally, it is time to do our isolate. Isolate. So when we do our isolate, again, essentially what we're doing is we are going to rewrite our answer, but in place of this c, we know c is that negative 6. So I'm going to rewrite y squared all over 2 is equal to 2x squared, not plus c, but minus 6. And all I have to do now is get the y by itself. So let's multiply everything by 2. Multiply by 2, multiply everything over here by 2. You're gone, leaving me with a y squared is equal to this 4x squared minus 12, which looks very familiar. It looks like on both A and B. C, you're out of the running. So those were the ones that were out of the running, right? So how do we decide between the positive and the negative? And again, we just have to check to make sure that initial condition worked. Oh wait, I haven't even solved yet. I'm getting ahead of myself. We have to square root, and then we get y is equal to either the plus or the minus of this square root of 4x squared minus 12. So which one is it? Is it plus or is it the bottom? Or is it the minus? I apologize. Well, we want a y that is negative. It told us, hey, the y value needs to be this negative 2. In order for the y value to be negative, we have to choose the negative. If this y value was positive, we would have to choose the positive. So in this case, we need the negative. So we want the negative version of this one, which is A. I'm not going to go ahead and prove it to you again. I'm just showing you that shortcut of how to decide between positive or negative. You just check the y value. If the y value is positive or negative, and you're done. Whew. Well, 11 and 12 were a lot harder than the rest of the problem. So thanks for watching the video, guys. That concludes our worksheet for 6-2 General Particular Solutions for AP Calculus AB. Thanks for watching.